Salutations to the examiners. My name is Oliver, and today, as part of our Engineers in Society course, we will examine a critical case study, the 2024 OCIM Polysilicon plant explosion.
This group consists of 5 members from different disciplines. Now let's move on to introduction.
On August 14, 2024, the OCIM Polysilicon plant explosion in Bintulu, Malaysia, became a tragic reminder of what happens when safety systems fail. 2 lives were lost, 10 workers injured, and the toxic chemicals released, all due to preventable technical and ethical lapses. The root causes: missing emergency valves, poor maintenance, and a culture that prioritizes cost cutting over compliance. This incident exposed critical gaps in the polysilicon industry safety standards, proving that without accountability, disasters are inevitable.
Hi everyone, I'm Farah and today I will be discussing the timeline of this incident. So let's start with the timeline. Starting in August 2024. On August 14, operation at the OC Malaysia plant were normal. Then a leak occurred in the hydrogen and silicon tetrachloride feed pipe. This led to overpressure, causing a major explosion and also fireball to occur. 10 workers were injured and rushed to the hospital, which sadly 2 later passed away on August 29 and also September 8. Investigation identified overpressure as the main cause of the incident. Further analysis found mechanical issue in the plant system. The company also responded with reactor repairs and safety upgrades after those incidents occurred. However, another incident in January 2025 triggered further investigation towards the company plant, showing ongoing safety concern.
The OCIM plant incident in August 2024 highlights three major technical and engineering failures. First, a process safety failure occurred when no emergency isolation valves were installed on the main gas feed lines to the reactor. This allowed hot reactive gases to escape during a rupture. It violates Regulation 10 of the SEMA 1936, which requires hazard identification and emergency preparedness. Second, there was an equipment failure. The main gas feed pipe operating under extreme temperature and pressure likely failed due to corrosion, erosion, and thermal stress. No proper inspection were done. This violates Regulation 14 of the Factories and Machinery, Regulation 1970 under the Factory and Machinery Act 1967, as well as Sections 15 and 24 of the OSHA 1994, which mandate safe and maintain equipment. Lastly, a material selection and corrosion control failure was identified. Inappropriate material use or improper handling of Incolloid 800H led to cracking and leakage. This violates Section 22 of the EQA 1974 and Regulation 32 of the EQA Clean Air Regulations 2014, which require proper emissions control and equipment maintenance.
I'm Daniel, and I'll be going over the ethical reasons for failure. Investigations identified the absence of emergency isolation valves and undetected corrosion in the piping as major contributing factors. These design and maintenance oversights represented not only technical failures but also ethical violations. According to Section 1.1 of the Board of Engineers Malaysia Code of Conduct, engineers must always prioritize public safety, health, and welfare, which was clearly not upheld in this case. This incident was not isolated. Between 2019 and 2024, OCI Malaysia experienced several other serious safety incidents, including fires, explosions, and chemical injuries, none of which were formally investigated or publicly reported. After the August 2024 explosion, the company deleted its only condolence message and failed to release a public report. These actions violated multiple sections of the Code of Conduct, including Section 1.2, which requires engineers to maintain direct supervision over their work, and Section 1.5, which mandates that safety violations must be reported to authorities. These failures also contravened the Engineers Act 1967 and the Registration Regulations 1990, exposing both individuals and the company to potential disciplinary action.
Now, I would like to present about recommendations to prevent future problems. The first one is enhance process safety design and implementation. Emergency isolation valves must be installed on main gas lines in hydrochlorination units to prevent catastrophic leaks during ruptures. Their absence shows a failure to foresee hazards, apply standard controls, and meet Regulation 24A of 1990 Engineers Regulations, which requires engineers to act with skill, care, and diligence. The second one is strengthen equipment integrity and maintenance programs. Routine visual checks and thickness measurements of high temperature, high pressure vessels are essential. The lack of proper mechanical or IM inspections likely allowed the failure to go undetected, breaching the regulations.
As future engineers, this case compels us to act. The tragedy wasn't just an accident, it was a systematic failure. But by learning from it, we can protect the lives, environment, and the integrity of engineering itself. Let's honor those lost by committing to change today.